So people are often surprised that when we're talking about vector analyses, that something as simple as selection is considered an analysis. Um, when we're in ArcGIS in particular, or in any GIS, the ability to do views, different views of the same data and queries is critical. So GIS provides a lot of different ways that you can view data. You can look at maps, which is kind of what we think of most of the time. We've been using the attribute tables a lot. You can use Arc Catalog and explore your data. You can also make charts. And so these are different ways of viewing the same information. Now, a query, by contrast, is a statement or some sort of logical expression. We use this to select a subset from our larger set. And so this could select records in an attribute table or in a database. And so these are data queries. And then we can also have spatial queries where the query is explicitly based off of the location. So queries are nothing more than a form of selection, and so I could be doing that query on my map and selecting individual things, or I could be doing it in a table. And let's talk about sort of four basic types. So one is sort of the scroll and select, and really these three here all fall under all fall under this sort of data query. And then the fourth is our spatial query. And so with scroll and select, I might just kind of scroll through my list and say, right, boom, I'm selecting the state of Arkansas. So that's pretty simple. So the way you do that, a lot of you've probably already done this. You may not have realized it, but when you're in the attribute table, you can go and you can just simply highlight. You can click on this button, or you can right-click and hit select, unselect. And when you've selected something and it's highlighted, then they show up as highlighted on your map as well as in your attribute table. So that's just your sort of scroll and select. Now set algebra, this is another sort of example where we're going to use operations that are sort of algebraic operations, and we can do this using the select by attributes function. And what we'll do is we'll actually use these. You can actually do SQL or Python structured queries. So SQL is a standard query language. It's used in lots of databases. So some of you may be familiar with that already. And the sorts of things you can do are use these basic Boolean operators. So double equals tends to mean equal in SQL. Less than does not equal. You can use and or, and we can also what gets returned. Boolean statements, a 1 is true, a 0 is false. And so in the select by attributes dialog box, what you tend to do is you choose the layer that you want to make your selection from, the method, and then you choose the field that you're going to base this selection on. So I may base this on the code. And so then what this query is, if I hit double click, I'd hit code, where code is less than or equal to 4 and code is not 0. And so I'd run that query, and then this is what it returns in that particular example. So that's examples of set algebra. The Boolean algebra that I mentioned briefly, these are things that depend on and, or, and not statements. So if I have these three regions, they could all be in one shapefile. These three circles could all be just different polygon feature classes in that. And this one is A, this one's B, and this one's C. The Boolean algebra, just a statement, well, return me back A or B. And so that's going to return these dark areas, versus A and B is the intersection. So this is a union, that's an intersection. And I could say the opposite of these things with not, so not A or B, that leaves that, or not A and B, that leaves everything but the intersection of A and B, or A and B, and then or C, and then that it does a combination of an intersection and union. So finally, we have spatial selection operations, and so these can be simple things like just highlighting an area on your map, and or they could be things that depend explicitly on location. So there's this notion of containment. So you could select all features that fall inside some geographic area. So I have a layer of dots. Return for me all the dots that fall inside this polygon, for example. I could do a spatial query based off of adjacency. So find me all the states that are that share an adjacent line. And so our example of the of adjacency, similar to what we saw before. This is out of your book. So for Arizona, then all the states that I share a line with. So I got 1, 2, 3, 4 of those, and even though Colorado is technically a neighboring state, it's not one that a line is shared with. And you could have a rule of adjacency though, where it's a node or line, and so then Colorado would be included because that node, they share a common corner. You can have features that lie within sort of buffer distance of another. So this is sort of an adjacency type thing, but it's based off of a distance. So if I have this streamline and I have all these trees that are surveyed in, and I say, right, give me all of the trees that are within 10 meters of the stream channel. And then you can you can use to do these sorts of things the select by location dialog box in ArcGIS. And so what you go through is you say, okay, well, what do I want to select my features from? So you choose the layer or layers, and then what is the thing? Is it that they intersect or that they touch or whatever the different method is, and then what you're comparing to. And so you can run that, and that's a real easy way to do a spatial selection query. Here's another example where we'll select features that are cell phone communication towers in this example that are within a distance of BLM wilderness areas. And so I say anything that's within 25 kilometers, select. And so all the brown dots here are my cell phone communication towers. All these pink areas are BLM wilderness areas, and so and then additionally these are pink areas that are highlighted here, and this is the result of running that particular spatial query. When you do spatial queries, one of the things that's nice, we mentioned there's different types of data that you can view for spatial analyses. So you can produce charts and graphs in Esri. They're not the best things in the world. Shannon may have mentioned to you in lab, a lot of us tend to export data out from our attribute table and analyze that outside in Excel or R or something else and make higher quality graphics. But you can do this within your map document. So for example, you can go to Tools, Graphs, and Create, and you can create a graph. And of course, if you've selected a subset of this, then that graph you can create graphs using all the data in a particular data set or using a selection of data, and we've just talked about different ways to do selections. And so another thing, just as a reminder, is that there are a whole lot of different tools for selection and for doing different geoprocessing functions, and sometimes you'll have access to those tools in the toolbox, but then they won't necessarily work. You need to make sure that your extensions are shown or are all turned on. And then also there's a lot of things that are just accessed from particular toolbars, and so you may need to turn those toolbars on. One example that is a really powerful form of spatial analysis is geostatistics, and so this is a statistical data exploration that you can do. And so to get to these tools, you need to turn on the geostatistical analysis toolbar, and you can simply explore your data in there and look at different sorts of histograms, semivariograms, etc., and try and identify trends in your data. So that's a very powerful tool. The workflows in here basically start out with you make a map, and you might kind of visually examine your data, and then you attempt to use these geostatistical tools, and sometimes you pre-process the data. You might transform it, you might detrend it, decluster it, etc., and then you're going to model the spatial structure of that data, and then you're going to use that to then define a search strategy. and then predict values at unsampled locations. And so within geostatistical models, interpolation models that we'll talk about later, allow you to do this. But in this context right now, this simple process of pre-processing data or just sort of examining data, looking at those charts is really useful to be aware of. These are some examples of those different charts. So here's a histogram, trend plot, semivariogram, normalized QQ plot, and Voronoi maps, all of which are ways of, in this case, of looking at your vector data sets and trying to better understand them. If you're not sure how to get started in there, you can just use the geostatistical wizard. We don't have any labs on this this semester. We got too much else on our plate, but there are some really good online tutorials and that you can take from Esri on doing these. There's a couple of free ones and walking you through the geostatistical toolbox. There's also a geostatistical wizard which will kind of walk you through the steps and ask you a series of questions to try and help you out. All right, so that wraps up that portion of this podcast on selection methods and sort of basic visualization methods. Next, we're going to talk about classification in this podcast series.